On July 1, 2025, a telescope in Chile spotted something moving through our solar system. It wasn't from here, not from our sun, not from any planet we know. It came from another star system entirely, and it had been traveling through space for who knows how long before it ever reached us. Scientists named it 3I/Atlas. It is only the third object like this ever confirmed in human history, and in June 2026, NASA's most powerful telescope pointed directly at it and found something that shouldn't be there.
Part 1. The Visitor. Let's understand what 3I/Atlas actually is. It's an interstellar object. That means it didn't form in our solar system. It formed around a completely different star, light years away, and was eventually ejected from that system, flung out into the emptiness of space. For millions, maybe billions of years, it drifted alone, no sun to orbit, no home, until it drifted directly into ours. This has only been confirmed to happen twice before. The first was Oumuamua in 2017, a strange, elongated, cigar-shaped object that showed no gas or dust at all. It just looked like a rock passing through. The second was Comet 2I/Borisov in 2019, which behaved more like a normal comet. 3I/Atlas is the third. But unlike Oumuamua, this one arrived active, with a visible cloud of gas and dust surrounding it. Scientists call this cloud the coma. That coma is what made this discovery possible, because gas and dust can be analyzed. And when NASA's James Webb Space Telescope analyzed it, the results were published in the astrophysical journal Letters, led by Caltech researcher Matthew Belyakoff and the Space Telescope Science Institute's Ian Wong. What they found was the first mid-infrared chemical fingerprint ever obtained from an object that formed around another star.
Part 2. The Methane Mystery. Here's where it gets strange. Webb observed the comet twice, once on December 15th and 16th, 2025, when it was about 330 million kilometers from the sun. Then again on December 27th, at about 380 million kilometers away. Both times it was moving away from the sun, heading back out into deep space. And in that data, Webb detected methane. This is the first time methane has ever been directly detected on any interstellar object. But here's the part that confused scientists. Methane evaporates extremely easily. It's one of the most volatile substances that exists. When a comet gets close to the sun, methane near the surface should burn off almost immediately. So why was Webb detecting methane at all after the comet had already swung past the sun? The answer scientists arrived at is almost poetic. The methane wasn't on the surface. It was buried deep inside, sealed beneath layers of ice, protected from the sun's heat. Only after the comet's closest approach did heat finally penetrate deep enough to release it. In other words, this comet had been hiding something for possibly billions of years, and we only caught it in the act of revealing it, and the amount of methane found wasn't small.
Researchers said the ratio of methane to water was surprisingly high, with very few comparable examples anywhere in our own solar system. Part 3. Why this changes everything. Webb also confirmed something else. 3I/Atlas is unusually rich in carbon dioxide, releasing far more carbon dioxide relative to water than typical solar system comets do. Two unusual chemical signatures, both pointing in the same direction. Scientists say this combination suggests 3I/Atlas formed in a colder, more distant environment than anything that formed around our own sun. Think about what that actually means. Every comet we've ever studied up close, every single one, formed in our solar system. Same star, same basic chemical starting materials,
Same general region of space. 3I/Atlas did not. It formed around a different star, under different temperatures, with a different chemical recipe entirely. And then it survived, drifting through the void, long enough to pass directly through our neighborhood, where our telescopes happened to be ready. Researchers described interstellar objects as planetesimals that formed around other stars and were later ejected from their birth systems through dynamical interactions. During their transit through our solar system, they offer rare glimpses into how solar systems other than ours actually form. We are not just looking at a rock. We are looking at a chemical sample from a star system that is not the one we live in. The lesson. So what does this all mean? It means that for a few months, a fragment of another star system passed directly through ours, and we had just enough technology at just the right moment to read its chemistry. 3I/Atlas is now moving away, back into the dark, back into a journey that may last for billions more years, drifting toward whatever comes next. We will likely never see it again, but for a brief window, scientists obtained something
Something extraordinary,
a direct chemical signature from a place none of us will ever travel to. This wasn't science fiction. This wasn't speculation. This was real data from a real telescope confirming that other solar systems built from different ingredients under different rules actually exist. And the only reason we know that is because for a few weeks in December 2025, a visitor from another star happened to pass close enough for us to finally listen.